Hello, this is Carlos Igreja, and this is a C++ program that I did as an exercise for my data structures and algorithms class in 2014. It's now 2016. I'm just going over and reviewing some old code that I have, and yeah, going down memory lane, I guess, or something. But anyways, what this is binary search. So I have this little GUI here, little program. And what it ultimately looks like it does is swaps the left tree with the right tree. That's the only thing that I saw really significant. But this will take a binary search, so we can go with some binary search trees. And I like binary search trees, so this ought to be fun. I'm going to go with build my own tree here. Pick two. And I want to start with something like 50. For the root, and then add like a 25 and 75. Then we can throw in whatever numbers. So I like a 10, 30. I don't want to go too much here. So that's going to be what on the left side of. Okay, so that's cool. That's like 3, height 3 so far, and I'll add a couple over there to the 75, so 60 and like 90 or even 100. Let's go 100, why not? Okay, so that's going to be my tree. And to get out of here, it says enter negative 999. So here it is, and there's the. Let's get some stuff here. It says nodes in order, so it ordered them for whatever reason. But yep, looks like it's in order. The pre-order, the way I inserted them, and the post order. Yeah, not sure the significance of that, but we have a 10, 30, 25, 60. And then 175 and 50. So let's see, we got a height of 3, like I said, which I was trying to actually do. So that makes sense there. Not sure exactly what the post order significance here is, without actually seeing the binary tree. Just putting them like this. I'm not sure exactly how I C-outed or printed got this. I'm gonna look at the code, but like I said, it's been a long time since I did this code, so but anyways, yeah, I'll just show off this program, kind of what it does, and if anything looks interesting, we can look at the code. If not, then yeah, just check out the program, I guess. Number of leaves is 4, so they have 4. Yeah, that makes sense, right? 4, the leaves is the end, whatever's on the end. So basically what I did was instead of 50, then we got the 25, 75, and then we added 2 to each one of those. So those would have been 2 leaves, but then we added 2 leaves to each one of those, so it's 4 at the bottom there, and that's the height 3. Yeah, if you can picture that. But yeah, these are the binary tree search tree is really a lot of fun, in my opinion. Definitely one of the most fun algorithms that I worked with before these swap subtrees. And yeah, so the root is 50 here, root is 50 there, and left. So what is this? Left subtree, right subtree. So all it does is take the left subtree and switch it with the right subtree. But it does look like it switches around a little bit, so that's interesting. Okay, so let's look at this before the swap. So we have the left subtree. So yeah, we have the 25, and then branching to the left of the 25, we have the 10, and then the right of the 25, we have 30. And this is off the 50. And then so this branches off the 50 to the right, 70, 75, and then the 75. So what happens with the binary tree is goes here and it tries to find where's the 60 go. Well, we got the 75. Okay, so let's check to the left here. because it's less than 75, and then it says, okay, this spot, it's null here, so we can put it there, and that node. So and then this is another node, so then it has two nodes there, and basically, so we get 100, it gets to 75, okay, that's greater than 75, so it looks to the right, and then there's nothing there, so it puts it there. And then that's how the binary trees work. So what happened here is we switched the trees, so that's interesting. So what happens when we do that? Let's see. So it looks like 75, and then so yeah, I guess it works to the left is the way. So if so it goes to the, yeah, basically just goes to the left instead. Kind of opposite. So if it's greater, it goes to the left. If it's smaller, it goes to the right. It looks like pretty cool. So greater than 50, we've got 75 here, and then greater, we get the 100, went to the left here, and then the 60 over here. So that's how that works. And same thing over here is going to go. So 25 is less than 50, so it went to the right, and then 30 is greater than 25, so we'll go to the left, and 10 is less than, so we'll go to the right. And you can see that, yeah, it's pretty cool. So I'm gonna hit enter there, and I don't know, that, I mean, that's about as fun as it's probably gonna get. I don't know what I did with this code, but I'll give it a try. Look at the main, and then we have this here. So it doesn't look like I did anything. Nope, right into the main. I didn't do any custom functions or anything like that. Just simple binary tree type here, and a little welcome to the program. Our options here. To obviously usually default, so I must have some default somewhere or whatever, and 2, so if 1, this is where the default is generated, and 2, we can generate our own user. So enter the numbers here, and then basically just tree root insert, just keeps going there until we exit out. And so I have the exercises, probably maybe some assignments I have to do, but exercises 1 through 4. And so let's see what happened here. So we got Inorder Traversal, okay, and that would be the in order, the pre-order, the post order. Now if I recall, I think I had to write these algorithms. So I'll have to look at that. Yeah, pretty much, because I wrote all like the algorithms for all the searches, and yeah, there's a lot of stuff in data structures and algorithms. It was yeah, definitely learned a lot. So if anybody's interested about that, if they're new. So yeah, so traversals, yeah, I'll be definitely doing more of that as well. Tree height, so tree height, that returns tree height. Number of nodes, tree node count, returns that. And number of leaves, so tree leaves count, returns that. Swap subtrees, so it says here print tree, swap subtrees, and so it says before, and then all I do is print the tree as it was, and then swap the subtrees, and then obviously deswap subtrees, and then I printed that. So swap subtree function, swap that around. So that might be interesting to look at. That was the most interesting that I saw anyways. And number of single parents, return single parent, and then we can exit out by using getCar, not system pause. So let's take a look at some of these. Let's see, what did I use here? The bsearch tree type, and I believe it's this one. Yep, bsearch tree type. So let's see what we have here for implementation. Doesn't look like much at all. Yeah, so yeah, I didn't see any code that I got the binary search tree here, header. Maybe the constructor is yeah, it doesn't make sense anyway, unless this I see this probably inherits the binary tree. Maybe take a look at this header. So yeah, it inherits the binary tree type, so that makes sense. And where is the functions that I wanted to look at? Should be in here. Let's see. So swap subtrees. I'm interested in that one. So basically it just reverses. Okay, this is the header. Sorry about that. I wanted the implementation. So binary. I mean swap subtrees. So we got the swap subtrees here, which I think was used. And then this is probably going to get called inside. Yeah, so past the root, and then so we go here, and so past the root, and then it just takes all of them apparently. So so swap subtree p left link, and for p right link. So we have a pointer. Okay, so we pass in, and we start with the root, obviously. Alright, so that's pretty cool. And we use recursion. Alright. Yep, so to check every possible node. So yeah, because we gotta check the left and right of each node. Pretty cool. So once we do that, go to the left, and then that will come in here, and if p is null, obviously it won't come in here, but it's basically gonna do this until everyone gets passed over here and filtered, basically, and then eventually it will come over. We have a temp points to null, so swap the subtrees, and then temp equals, so we just kind of set this as a null node, but pointing to a null node, and then we can set it to this link, and then that link equals the right link, and then yeah, your basic replacement here and sorting algorithms. So yeah, just store here, and then yeah, store this one here. Now we have this stored in a safe place. We can overwrite it with this right link, and then that right link will get past the left link. Just switch it around, real simple, and that's pretty standard with a lot of sorting algorithms. So yeah, that's cool. Yeah, I like the recursion. Like I said, it's been a while since I've seen this. Now the I'll check out the Inorder and stuff like that, although I don't really. So basically Inorder, I think I had to write these algorithms. So what do I have here? I got a pointer, see out that info. It passes in order, so it calls itself. Yeah, once again, recursion. Check each one. So in order, just in order. All right, so let's look at this. Cannot equal. Now, obviously, we just want to see in order. And so I have a C out between in order. So in order, all right, I'm gonna have to figure this out in my head here. So we pass into the root, whatever, 20, and then so that's the left, and then we go over to the left link. So it's going to be something like it's going to have a left and a right, most likely. So let's say we have a 10 and a 30. So for the left is 10, and that will go in here, and then that 10 will check. So basically all the left will and then so left will go in here, and then eventually it's got to output, and then the right will go in here, and basically the left, and then it will output the right. So yeah, that makes sense. So we'll pass in the left will output, and then the right, which so if you think of the tree, that's that will be in order, right? So so if we think of, say, 20, and then it goes over to the left, 10, and then it will have that 10 will have, say, I don't know, like a 5 and a 6, or no, it will have 5 and 15, right? So it'll output that 5. All the left links first, so which are, yeah, and then the right links. So up to that node, it'll output all the smallest to the basically all the way up, right? So that 5, then I'll have like a 3, and then a 2, and then a 1. So it'll go 1, 2, 3, 4, all the way up until that left link, and then it will go actually down the right side. So yeah, that's how this works here. Yeah, it can be a little confusing. Yeah, so I mean this stuff, you know, takes a little some pretty tough thinking. That's for sure. The data structures and algorithms, all these yeah, but definitely get a great understanding of how these the very low kind of, I don't know, I think this pretty low level stuff, a lot of high level stuff, you know, you just, you know, call like you know, call something, use it, and you don't really have to get in here and worry about this stuff too much. So this really gives you a great understanding of how all this stuff works, algorithms, and the best way to approach a lot of problems, or all these different types of algorithms in your toolbox, when efficiency and performance is different, you know, is a concern. So, you know, yeah, if anybody was wondering, yeah, this is pretty much the type of stuff that yeah, I was doing with data structures and algorithms with C++. So yeah, anyways, yeah, that's pretty much, you know, about it that I'm gonna cover here. And yeah, hopefully you enjoyed watching, and thanks for watching. Goodbye.